All right, so that brings us to the cloud service. So I'm going to try to demo the cloud service. So many of our customers in previous years, they were asking us, so what do we do with this NIRvascan spectra, the absorption spectra? So how can we get the sugar content, the fat content, the protein content? And our answer was no, you have to do your own chemometrics. But now we are in a position, since a few months ago, we have introduced our cloud service, and it's free. You can go ahead and try it out. This is the link for it. Basically, you could upload all your spectra on the cloud, and you can make NIR profiles. You can plot your profiles. You could make basically pre-processing, apply pre-processing to your spectra, the second derivative, Savitzky Golay, and you can make predictions using PLS model, or you can do sorting using the PCA model, principal component analysis, or linear discriminant analysis. So this has made it very easy for our customers to basically use this cloud for free to get the ingredients that they're looking for, or to do their sorting. For example, plastic sorting, different types of plastics. So let me show you how this works. So I'm going to go on the cloud platform. Just a minute. So Nirvacloud.ai. Nirvacloud.ai. Yes. So this is the cloud platform, and I'm logged in right now, but any one of you could go there and basically just register. You need to register some information, including your email, your name, and then you can get started to go into the cloud. So the first thing to do would be to click on analysis. Once you click on the analysis, then you'll see all the different features that appear in here. So you can put your spectra there. These are all different spectra, but normally the way we do it is that we upload profiles, and this is what the first page also showed us. So upload profile. What do I mean by that? What I mean is that you make a profile, just like in that Heather Brooks page that I was showing, how she set up the spreadsheet. Same thing here. So on the first row, you have all the wavelengths from 900 all the way to 1700 over here. And then you have your protein contents here on the first column, and these are all the absorbances. So this one has, for example, 38 spectra in there. So once you do the measurements and you create this file in Excel, then you can upload all of this all at once. You don't need to do it one by one. So you can just give it a name here and then choose the file and upload it. So here, for example, I give you some example. So this is one profile, or number of spectra is also shown here. This is another. So you can see the full range. These are labels. These are the protein contents that are automatically extracted from the Excel file. You can hide the label if you want to see it more carefully. You could increase the resolution. This is low resolution. This is high resolution. And so you can display your spectra. Then the other thing that you could do is you can apply the Savitzky Golay filter. So if you go to add, for example, then you would give it the title, the window length, the polynomial order that you want to fit, how many derivatives, and then you will choose one of these profiles here, and not from the spectrum, but from the profiles, and they say save. And that will apply the Savitzky Golay of that number of points and that order of derivative to your profile. So you can look at some of these, for example. So these are Savitzky Golay. So you can see this is the second derivative spectrum. In high resolution, it looks like this. So you can see that there are two, I need to explain, there are two suffixes here. One is called SG Pro. All the SG Pros are in here, but later on when we go to PLS models, you also see there may be other profiles. Let me look at the SG filters one more time. SG Pro means it's from the profiles. So I'll explain that later. There is SGPLS. So once you make this, you can apply your Savitzky Golay. But for making the calibration model, you don't have to start from the SG filter because it is also included in the PLS model. So you can go add a PLS model and you give it a title, a number of components you want to use, and what is the calibration profile that you want to use to apply to make the model, and then you can say apply SG filter, and that same menu appears here too. So then you would save it, and that will give you a PLS model. So I'll show you one PLS model, for example. So here I go to this PLS model. So this PLS model are already, you have the parameters, 10 components, a Savitzky Golay of 23, and its model itself has the RMSE of 0.3. Looks like this. And then you can apply this to any one of these, any one of these other test files, which has already been applied. The Savitzky Golay has already been applied to it. SG Pro. So if I choose, for example, this is the wheat. So for example, I choose this, and then I would say, apply the model to predict. Then it gives me the predictions. So if you scroll over this, it will tell you what the actual number is and what the predicted is. So you can also get the results, the score, the R-square of prediction, and also the true prediction. You can also export the results to an Excel file to tell you that what is the actual value and what is the predicted value. So it will give you all this information. So that's the one PLS model. SG, these are all the PLS model, right? So the other feature is for sorting, we have a customer that does the plastic sorting. So we make LDA models. So for example, here, linear discriminant analysis, we have an LDA model for classifying different types of plastics. So each one of these are separated in different piles, type 1 to type 7. So I have recorded a video on this that I'll show you later for plastic sorting. So one thing about plastic sorting is that you have to get different profiles. So let me actually show you the different profiles here. Sorry, this is not. Different profiles should be shown here for PCA, chemometrics, LDA, and no, actually it is for customers and plastic recycling. So each file of different type should be in one, you can say in one Excel sheet. So this is plastic type 1 is in this. You can see it's only type 1, and all the spectra are given here. The wavelength is on the top, and you also have type 2, type 3. So for different types of plastic, the spectra are in different files, and then you can upload all of these at once. So you go here, when you want to make your LDA model, you say add LDA model, and then you would say, for example, webinar, you give it a name, webinar March 16. a number of components too, and then you would choose all those plastics. 5, 4, 2. No, this is from the, yes, this is, yeah, 5, 4, 2, 1, and so on. And then you would save. Okay, so this is the LDA model that uses all of those plastics. So you can see they're separated into different piles. You also have a PCA model, same method. You have to generate these Excel sheets that have different types, and then you give it a name, and all of them you can upload at the same time and then make a PCA model by using the @ Okay, so these features are very useful. The cloud service is free for people who use NIRvascan or purchase NIRvascan. And we also give you support up to 5 hours for you to, if you have any issues, you want to learn how to use the cloud more. And I would suggest if you try it out, it's for free right now. There's also some security features. You know, you could choose your data to be secure. In that case, you will be the only one who will see it. But if you leave it open, then everyone else can see it as well. So here are some examples that I showed: the cloud service, the PLS model, the LDA model. You can create these.